All right, so today we're going to be talking about the lateral and surface area of a cone. So here are our formulas. Our lateral area is pi r times the slant height, and our surface area is pi r times the slant height plus pi r squared. So again, that's our area of our base, which is always going to be a circle in this case. I do want to point out that again, we are going to have right cones that are standing straight up and down and oblique that are more slanted. And again, the slant height is on the outside. Think about standing at the top at the vertex and sliding down the outside of that cone. So if we look at these conical slate roofs, we'll see that they have a height of 16 feet. So that means from the center all the way up to the top is 16 feet and a radius of 12 feet. All right, so again, from the center to the side, that's 12 feet. So if we want to find the lateral area here, so remember our lateral area formula is pi times the radius times the slant height. Well, we have the radius, we have that that's 12, but we don't have the slant height. So we need to find that, and we can use that using the Pythagorean theorem. So I have my 12 squared plus 16 squared equals L squared, or my slant height squared. All right, so I'm just going to go through and solve this using the Pythagorean theorem. So I get 144 plus 256 equals L squared. All right, and I add those together. It'll give me 400, and then I'm going to take the square root of both sides. So I get that my slant height is 20. All right, so from there, I'm actually able to calculate my lateral area. All right, and again, my lateral area is just like if you're thinking about this roof, it's just the shingles. We don't care about what's underneath the shingles. There's no base to this. It would be kind of open, so to speak. So my lateral area would be pi times my radius, which is 12, times my slant height, which is 20. All right, and I want to encourage you again, whenever we're working with pi like this, let's try to get an exact answer first. So I'm going to do 12 times 20, which will give me 240 pi. So again, this will be my exact answer. And then I'm going to multiply that out to get roughly 753.98, which would actually round up to 754.0. All right, so that would be my lateral area. So now let's look at the surface area here. So again, let's remind ourselves of the surface area formula for these cones. So we have pi times the radius times the slant height plus pi r squared. So we need the radius and the slant height, and we have that. We have the radius equals 1.4. The slant height is 3.2. Now we're just going to plug it in. So I have pi times 1.4 times 3.2 plus pi times 1.4 squared. All right, so now I'm going to multiply this out. So I get 1.4 times 3.2 will give me 4.48 pi plus 1.4 squared will give me 1.96 pi. So to get my exact answer, I'm going to add these together. I'm going to get 6.44 pi. All right, and then to get my rounded answer, I'll multiply that through. So I'm going to get 20.2. Right, that would be my surface area. If I wanted my lateral area, I could get that from here. So my exact answer for my lateral area would be 4.48 pi, or I could multiply that out and get 14.1. All right, so there are my two answers. Now, what I want you to recognize here is that we want to be finding the radius, but we're given the diameter here. So just be careful. I know you guys know how to find this. So the radius, we just cut this in half, so we get 7.4. And then our slant height would be 15. All right, we'd still be able to plug this into our formula. Okay, so we'd have pi times 7.4 times 15 plus pi times 7.4 squared. All right, so what I did was I multiplied through and then I combined my like terms to get my exact answer. Then multiplied that by pi to get my surface area of 517.6. All right, and again, to find your lateral area, the exact answer is 111 pi. And if we multiply that through, we would get roughly 348.7. Alrighty, so there's our lateral and surface area. Okay, so next we're going to look at these two cones here. Again, the information you need for this first one is all here. You have your radius of 0.8 and you have your slant height of 2.2. All right, so I'm just going to plug this into the formula. So pi times our radius, which is 0.8, times the slant height of 2.2, plus pi times our radius squared. All right, and so I took the information we plugged in, I multiplied through, combined like terms to get an exact answer of 2.4 pi, multiplied that through to get 7.3 as my surface area. And then my lateral area would be 1.76 pi, and I could multiply that through to get 5.5. All right, now this last one here on this page, you do not have the slant height. You have the height of the cone and you have the radius. So we'd use that to form a right triangle to solve for the slant height. So you have the legs, you need to find the hypotenuse. So you have 6 squared plus 7 squared equals our slant height squared. All right, we're going to add those together and we get 85. And then we're going to take the square root of that. So our slant height will be 9.2. All right, so then we have our slant height is 9.2. We have our radius of 6. We're going to plug this in. All right, and we're going to multiply through. All right, so I did all my math, giving me an exact answer of 139.84 pi for my surface area, which ends up being about 439.3. And then my lateral area is 55.2 pi, and that will give me 173.4. All right, and this last page just recaps all of the formulas we've talked about over the last 4 classes. So your lateral area formulas and your surface area formulas for your prism, cylinder, pyramid, and cone. Do remember that if you know your surface area formulas, like these longer ones with all the stuff written out, if you know those formulas, you knowing these 4 formulas will give you the 8 formulas you need to know for your lateral area and surface area for these kinds of shapes. So remember that the first little piece before the plus sign is your formula for your lateral area. All right, and then we're just adding on the area of the base, whether it be here where we're adding on 1 base or here where we're adding on the area of 2 bases.